When you're automating a manual assembly or machine tending process, of course, you're replacing a human being with 2 arms and 2 hands. Now, in many cases, automation would require tearing apart a line and extensive redesign, but of course, that's costly and often it's an obstacle to automation. I'm with Paul Marcovecchio, he's sales manager with Kawasaki Robotics. Paul, I understand that we're standing next to a robot which has 2 arms like a person,
Yep.
that you could plug in to an assembly station and replace a human being without radically rearranging your assembly line.
Exactly right. So with the Duaro robot, a couple of key features is it's portable. And with it being portable, it gives you a lot of flexibility to being able to automate a process that may have a lower batch run or whatever the case is, and move it to another process, which makes the investment very flexible. For capital equipment investment, say with a traditional robot, it's dedicated to that process or that project. Here you can move it around in your facility. It requires 220 and an airline.
Now, in that case, you say move it around. Would you move it around typically, for example, mount it on wheels and manually push it around? Could you mount it on a gantry or a track? How would you do that?
It has casters, and then you can level it off to the process. And from there, you can actually wheel it like you would a cart.
Now, in most general purpose robotics, the ability to move the robot is one thing. Another thing is to be able to actually find what you want. For example, pick a part out of a bin or pull it off a conveyor and assemble it to something else.
Sure.
Now, and they usually require some level of programming or arranging fixtures so that the robot knows where they are. How does that work with this system?
So we'll start from the basics. The robot itself has 2 arms. They can work together or independently, so 2 separate processes. And it's an app that you download to program the device, and it's lead to teach, which that means is you actually move the robot physically where you want to and record that position. So now that interface is very user-friendly, and it can take an operator who is doing that manually and make them into a robot programmer very easily. So from that point, you move the process and move the robot where you want to. You could be loading and unloading a machine. The robot has integrated vision, so you can do vision inspection and that sort of thing. So it's really dependent on the application that you have in mind. But with a workforce right now where it's limited and it's really hard to find employees to do a very monotonous task, it's a good fit for that segment.
Now, I've noticed that there's no guarding around this machine here. This is collaborative robotics.
Yep, it's collaborative. It doesn't require any safety fencing or anything like that. Mind you, if the process itself isn't collaborative, you want to make note of that. But itself, the robot is padded. It has force control. It's very safe to work around.
Now, you mentioned machine vision. Of course, a big part of the expense, which many manufacturers, sellers don't understand, is that fixturing can often be quite pricey, because you need component parts to be exactly to the millimeter where the robot expects them to be. It sounds like machine vision can maybe loosen some of those constraints a little bit.
Sure, it can do part identification, it can offset the robot's path. It really adds that added artificial intelligence to a system. And with the Duaro, it's already integrated in, and the interface is on a tablet. So it's one stop, so much so that part of the Internet of Things, the interface itself or the robot system can actually send you messages on its productivity, if it's down, if the operator's interrupted it. So it's really intuitive.
Paul, if you could give a single piece of advice to potential end users looking at this technology,
sure,
and not sure where to implement it, what's the first step? What would that piece of advice be?
I would say in terms of in the collaborative space, we recognize that speed is not going to be as fast as typical automation. High-speed automation is dedicated automation, requires fencing, requires safety concerns. In a collaborative process, you have no fencing. There isn't necessarily the same amount of control structure as required in a dedicated automated system, but it also operates at slower speeds. Part of the collaborative is speed control and force control. So if you have a very high-speed application, you would still probably go with a traditional automated system. But if it's a current operator task that at operator speeds, collaborative robots are definitely the way to go.
Paul Marcovecchio says, for replacing a human operator in a light assembly operation, think about 2 arms and think about collaborative robotics.